to your point, I totally believe that right now the intent framework's constraint system is actually very, very limited and simple, and there's a reason for that, right? So it's because the UVM, as kind of precisely mentioned, is not really built for that. And but with Brevis, as we'll kind of talk about later, you can actually expand the type of constraint system you can do in intent-based frameworks in a very, very kind of amazing way. Because now you will have better access of data, better access of compute in an object-oriented fashion. So, without further ado, I'm Mo. I'm here to talk about Brevis. Brevis is, so, through this talk, hopefully I can deliver to you how you can build data-driven dApps with a Smart ZK Coprocessor. So, the goal of Brevis is really to, how do you actually do this? Okay, this works. The goal of Brevis is actually to introduce a new kind of a construct in Web3 application, which is called an asynchronous architecture, asynchronous computing architecture. Now, what is asynchronous computing architecture? Well, let's take a review in the history of Web 2 itself. So Web before 2000 is actually built in a synchronous-based architecture, where you have this monolithic web server serving everything for the user in a sequential manner. The web service doing request handling, access control, computing, data access, literally everything. It was very clear back then, this type of architecture would not be able to scale to support the level of growth we were seeing in internet early days. So this is how we evolved in the last 20 years into this new architecture, where you have web server still, but the web server itself become a very, very thin piece of software that is just acting as a coordinator between the user and specialized backend services. The users will be able to send high concurrency requests to the web server, and the web server will just turn around and relay the request to different specialized services, and these specialized services will do the processing and send callback functions back to the coordinator, so the web server can assemble and kind of coordinate between these return data and represent to the user a final coherent result in the web return. So this is how you are seeing web, Twitter streams, Facebook streams. Every single Web 2 application you're using today is built on this type of architecture for scalability. Now, if we look at where we are in Web 3 today, it is actually worse than Web 2 before 2000. We are treating essentially blockchain VMs, EVMs, the Solana VMs as this monolithic web server backend. Everything's handled by smart contract, and it's basically essentially handled in a sequential fashion. The worst thing here is that the performance is really bounded. It's for any single blockchain, the computation is bounded, the data access capability is bounded, because fundamentally, even with layer 2s, everything is running in a replicated compute, replicated storage, due to the high overhead of communication, fundamentally limited the computation power rooted in the consensus protocol itself. So and simple example that I always go back to is if you want to build a trader loyalty program in Uniswap, let's say, you see this type of trader loyalty program everywhere in centralized exchanges. Say a user traded $30 million in the last 30 days. In the next 30 days, he should be getting a 30% fee discount. You see this everywhere in centralized exchanges, but you don't see this in any of the DEXs. Why? Because if you want to do this, you have to pay 8 hours of the block time and 40K transaction fee just to access a user's historical trade, in the last month for a single user. This is because right now on blockchain, there is no trust-free access and the computation capability possible based on the historical on-chain data, such as storage slots, transactions, events, and all that. So what Brevis is trying to do is Brevis is trying to solve problems like that. So with Brevis, what we're trying to position blockchain is a simple coordination between different off-chain computing components. Of course, many of the assets related to computation are still going to happen on blockchain and recorded on blockchain, who has how much asset, who transferred how much asset to who, but the whys and hows of these asset transfers should be offloaded to an off-chain component to do the computation. But the most important thing here to note is that Because we're talking about Web3 and we're talking about blockchain applications, the most important thing is to ensure the entire computation cycle is maintained in a trust-free environment. That is to say that even though we're introducing this asynchronous off-chain computing component, everything should be, every computation step should still only just rely on the trust assumption of the blockchain itself. This is where the ZK comes into play, where the computation process can be run in the ZK domain so that the result is verifiable on the blockchain directly without relying on any third-party trust whatsoever. So, there are many components of Brevis, but we already have something called the ZK Coprocessor, Brevis ZK Coprocessor that is already in production. So I will just dive a bit deeper into this. So for Brevis ZK Coprocessor, what it does is it can generate ZK proofs for arbitrary computation across any historical on-chain data, and they allow smart contracts to use that data trust-freely in their business logic. So to build a Brevis-powered application is very simple. There are really just 3 steps. The first is that you specify what type of data you want to read. Second, you run computation on top of this data based on your business logic. And finally, you bring the data back to the blockchain, verify it, and then use it in your smart contract. So how exactly does that work? First of all, for data access, Brevis today, right now, if you look at our SDK, already support a vast majority of the data access that is available on blockchain today, including storage stuff, which is like the variables in different smart contracts, the NFT ownership, the token balances, and these type of things. And not only that, but also transaction receipt that contains transaction events and the transaction themselves. So these data, using these data, you can actually access users' historical actions and interactions with different types of applications and derive insights and the computational result out of that. And of course, block information account state as well. So the read process using Brevis is quite simple. You just specify what type of data you want to read and add it here. This very simple code snippet is how you can access the user's Uniswap trading volume on a particular pool. And the second step is to do compute. So Brevis is based on ZK, but you don't actually need to write anything in ZK circuit. We provide a very high-level data stream API with MapReduce, filter group by, or zip, this type of primitives. So you can actually collectively process the data you get in the first step and generate the computation result easily. So this 3 lines of code will allow you to compute a Uniswap trading volume of a particular user using Brevis. And finally, after you generate the proof of the computation and the data itself that the computation is based on, the proof itself will be sent back to the blockchain via a standard callback function. This is where you also need to implement the callback function in your smart contract to receive the co-processing result and use that in your business logic. So to build the same thing with Brevis, now the pattern becomes that the Uniswap smart contract will be able to send out a request saying that, okay, now I want to get a trading volume of a particular user to a on-chain processing contract. The on-chain processing contract will in turn invoke the ZK coprocessing functionality of Brevis. Brevis does the computation and then send a trading volume data through its callback function to let the Uniswap report what is the trading volume, what is trading volatility of a pool, and so on and so forth. So that you can do things like volatility-based fee, trading volume-based fee discount, and many things around that time. And Brevis is super high performance. Proving trading volume of user across millions of transactions in Uniswap only costs you about $1. Sorry, I got a cold last night. So there are many things you can do with Brevis. Data-driven DeFi is one big category. I talked about VIP trading programs, but volatility-based fee pricing, volatility-based pricing, but many things like, retrospective farming reward protocols where you value each LP not based on their time length of liquidity deposit, but actually based on the amount of fee generated by each of the LP compared to all the other different LPs. But very importantly, also on the consumer-facing applications, one thing I do want to mention, it goes back to Kevin's talk, is that Brevis can actually expand the type of constraint system you can do in the intent frameworks. That Using Brevis now, you can have a user to specify my intent is that I want my trade to be executed when the price is moved to a certain point, or I want my trade to be executed when the volatility is so high, or I want my liquidity position to be rebalanced if the time-weighted average price already deviated from my range for like a consecutive 2 hours or 3 hours. These type of future conditional intent is something that is possible to build with Brevis, because Brevis now have the capability to verify and prove on chain that certain triggering event actually already happened. Sorry, and then finally, there are a bunch of data and computation power infrastructure, such as cross-chain. Because Brevis supports cross-chain functionality natively, so we can have the capability to build cross-chain oracles by the capability of relaying the block header from one blockchain to another using ZK. So that once the block header is available, you have access to every single state that you can imagine in a different blockchain. So imagine that you just launched the rollup and service chain as an application chain, and you don't have any access to any Chainlink oracle. But with Brevis, you can easily get the capability to access an Ethereum Chainlink oracle price feed on your newly launched rollup as a service application chain. And there are so many different more use cases for Brevis as well. So finally, I just want to touch base on how you can use ZK frameworks in general. When you're talking about off-chain verifiable computing using ZK, there are two models actually you can choose in Brevis. One is, of course, you do this in pure ZK. It's very straightforward. So you do everything in ZK Compute and you generate proof. The second model is called crypto economic security plus a ZK native proof. So this is kind of an optimistic co-processing model where you have a proposer to propose an initial claim saying that this is the co-processing result that I proposed without actually going through any ZK proving process. Now, just like an optimistic rollup with a ZK fraud proof challenge, you can now submit a ZK native proof to challenge that if a challenger detects that there is a fault in the co-processing result. With this model, you can actually get much lower cost, but you don't actually lose any security. It is not to say that you are actually dependent on the optimistic proposer now, because you still have the ZK security as the last line of defense. You're just trading off a bit more latency with much lower cost. And of course, you can support more features using this model, because now you can prove things like proof of completeness and proof of non-existence. So yeah, I will just stop my talk here and see if there's any quick questions.
Yeah, before we go into the question session, just like a reminder, people in the back, you can feel free to find and sit in front. And also, like I actually have one question, like because a native proof is kind of new, and I don't know what's the current stage of this ZK system.
So when we're saying like native proof, so there's a ZK native proof paper, but that's kind of not related to the architecture that we are mentioning here. The native proof in the paper is basically saying that you can verify if a proof is wrong without actually verifying the proof itself. But what we're trying to do here is more pertaining to an optimistic rollup with a ZK fraud proof, so that you're not sending your computation request directly to a ZK prover marketplace or ZK prover network. Instead, you send it to a proposer network. And in this case, we implement a ABS as an optimistic proposer. And the proposer will propose a result without actually generating any ZK proof. Because we're using the ABS, so it does come with a default security of proof of stake security that you can directly use if you want. But if you don't want to directly rely on the proof of stake security, you can wait a sufficient time window to initiate challenge if needed. So that's basically how it works.
Got it. And for DeFi and ZK space, are there any new use cases you're exploring in the future or in your pipeline you want to mention?
Yeah, I mean, every DeFi protocol right now is moving towards modular-based design. not just like DAXs, but also lending protocols, perp, and everything. So many of these things will now start to be powered by more insights for launching historical data to implement things like protocol fee boosting, revenue stream boosting, user engagement, user retention, and acquisition features. So yeah, we are seeing a wide landscape of DeFi protocols, both old and new, moving towards that architecture.
Cool. Yeah. Any more questions from the audience? And audience in the back. Okay.
I'm just kind of curious how much these computational requests cost, like the end users.
Yeah. So very concretely, so this is like a kind of computation cost reference. Right now, using Brevis, it costs about $1.4 in off-chain computation resources if you try to verify and generate proof of a user who traded about 10,000 transactions on Uniswap, like for a certain period of time. So that is like already extremely scalable, because if you think about Uniswap right now, in the entire Uniswap trading amount on a monthly basis is about 800K. It's not that much actually. So it can actually handle very large scale use cases already using pure ZK. And the verification cost really depends on different chains. If you're talking, but from absolute gas perspective, it costs about 200K gas to verify a proof on chain. But the benefit of ZK proof is that you can actually aggregate multiple proofs together to amortize that cost. You don't actually have to verify each of the proofs. You can generate individual proofs and aggregate these proofs as a single one with a bit of trade-off on latency and verify that. And therefore, like the cost of verification is not really a major concern here.
Thank you.
Okay, one more.
What is the art of collaboration of ZK proofs where they can be used on intent-driven protocols? Like say a solver that is solving intent routes on Uniswap X or Caswap, could it go to like a ZK Coprocessor to check if a user is eligible for a free trade discount, and how would that workflow be like?
Yeah, so for intent, we are more looking at things like kind of a trust-free intent automation, where the user, instead of have to specify the intent he wants to access right now, they can now specify future intent based on conditional triggers. Basically saying that, okay, I only want you to swap my USDC to Uniswap if Uniswap's price reduced to a certain level for a certain period of time. It cannot even just be a single point in time. The user can specify the constraint in a much broader way and in a conditional and future-oriented way. So this is like how we are seeing many of the intent protocol right now is using Brevis to build their new framework for.
Okay, thanks.
Thank you. Next up.
Thank you.
Thank you. Next up, we have Kian from Mo Dong.